Okay, Algebra 2 fans, our topic for today is variation. And before we start, let me tell you your joke of the day. I heard there was a new store called Moderation. They have everything there. Okay, now that you process that, so our goal, this is actually a review of some Algebra 1 concepts because we're going to be solving problems involving direct, inverse, and joint variation. You've done direct and inverse back in Algebra 1, now we're going to talk about joint variation. So the way that I think about this, when it's a direct variation, I think divide the variables. And what I mean by that is we take, usually it's y and x, so I take y and I divide it by x. So direct, divide. The definition is that y varies directly as x if there is some non-zero constant we call k such that y over x, y divided by x equals k, the constant. Now if we want to solve it as y equals, we can take the x, multiply both sides by x, so this becomes y equals k times x, and then k is called the constant of variation. K is the constant of variation. Now this should look familiar to you because y equals kx actually looks a lot like y equals mx plus b, except the only difference is that there is no b. The constant of variation, the k, is actually like the slope. So because there's no b value, if you were to graph a direct variation, the picture is always going to be a line that goes through 0, 0, because the y-intercept will be 0 with that. So that's visually what's happening. Now we're going to concentrate more on actually solving these things and what that will look like. So number one, if y varies directly as x, so the key is it's a direct variation, y equals 16 when x equals 4, find x when y is equal to 30. I'm going to set this up as a division problem, y over x. Now they give you one situation, y equals 16 when x is equal to 4. So I'm going to write that as a fraction, 16 over 4. Now they give us a second situation. In the second situation, they say find x, so we don't know that, when y is equal to 30. So we're missing part of this. We have 16 over 4 equals y divided by x is 30 over x. So what we're doing is we're making a proportion. To solve that, we can cross multiply. So 16x, 16 times x, equals 4 times 30, which is 120. And then we solve it. We divide by 16. And what we'll get out of this, we'll get a decimal. We get x equals 7.5. And that's it. That's the answer. So you can find values, direct variation. You could also write the equation. They may ask you for the equation. Well, the equation, I'll do this on the left side here. Again, y divided by x equals the constant of variation when it's direct. Well, if I take 16 and 4, which was one of the situations they told us, that would equal the constant, which is 4. So the equation, you can write it two ways. You can say y divided by x equals 4. But if you wanted to write it as y equals, which is normally how we would write an equation when we graph it, we would multiply by x. On both sides, we get y equals 4x. So that would be the equation. The solution to our problem was 7.5. Okay? So for number 2, if y varies directly as x, and y equals 9 when x equals 6, find y when x equals 8. So again, they give us a situation. Y equals 9 when x is equal to 6. So I'm going to write as division, 9 divided by 6 equals, find the y value when x is equal to 8. Now this time we do not know the y value, but it's always y on top. Y divided by x, which is 8. And now we solve it. Cross multiply, we get 6y equals 9 times 8, which is 72. Divide by 6, and y is equal to 12. If you wanted the equation, you could find the constant first. You could say 9 divided by 6 equals k, which is 3/2, or 1.5. And the equation would end up being y equals 3/2 x. Okay? But the idea is that when you're solving the problem, you are dividing the variables first. Write it as y divided by x. Now, if we look at a word problem here, the weight of an object on the moon varies directly as the weight on Earth. With all of his gear on, Neil Armstrong weighed 360 pounds on Earth. When he became the first person to step on the moon on July 20th, 1969, he weighed 60 pounds. Tara weighs 108 pounds on Earth. What would she weigh on the moon? So it looks like we're comparing two things. We're comparing the weight on Earth to the weight on the moon. Now, let's see, the weight on the moon varies directly as the weight on Earth. Technically, I should do this as m over e because the moon weight came first, varies directly as the weight on Earth. So m over e, that's how I'll do it. So, with all of his gear on, Neil Armstrong weighed 360 pounds on Earth. When he became the first person to step on the moon, he weighed 60 pounds. So his moon weight is 60, his Earth weight is 360. Now Tara weighs 108 pounds on Earth. I'm putting the Earth weight on the bottom, so 108's on the bottom. What would she weigh on the moon? I'll call that x. Once you have the proportion, you solve it by cross multiplying, so we'll do 360 times x equals 60 times 108, which I'm going to punch that into a calculator, and we get 6,480. And then the last step is divide by 360. Okay, I'll show you the calculator here. Divide that answer by 360 and 18. So her weight on the moon is 18 pounds. Direct variation, divide the variables. Direct, divide. All right, so let's look at inverse. Well, direct is to divide. Inverse is going to be to multiply the variables. So this time we'll do x times y. Y varies, as the definition, y varies inversely as x if there's some non-zero constant k such that x times y equals k. Now if you were to solve for y, you would move the x to the other side by dividing it, and you would get y equals k over x. Now that's not going to be a line. If you draw the picture for that, that type of equation is a rational function. It looks something like this. So you would be dealing with potential asymptotes, vertically and horizontally. You can't have 0 in the denominator. That's why they say non-zero constant k. All right, but in terms of solving it, the key is we're going to multiply the variables. So number 4, if y varies inversely as x, that means we're going to multiply. Y equals 8 when x equals 5. So I'm going to do 5 times 8. It doesn't matter the order that you multiply. X times y or y times x doesn't make a difference. Find y when x equals 10. So the second situation, we've got x is 10, but we don't know the y. Let's write that as 10 times y. Now we solve, we get 40 equals 10y. Divide by 10, and we get 4 is equal to y. If you wanted to write the equation is x times y equals k. So if I had done 5 times 8, the constant would be 40. So the equation would be xy equals 40, or I could then divide by x and we get 40 divided by x. That would be the equation. Okay, again, we're just solving it, but if you wanted to graph it, this is what you would be graphing. Take the constant of variation, which is 40, and then you can write it this way. All right, let's do number 5. If y varies inversely as x, y equals 15, when x is 21. Find x when y is 27. Well, we're going to multiply 21 times 15, x times y, equals x times y. Find x when y is 27. So I'll write that as 27 times x. Okay, so we'll work that out here. 21 times 15 gives us 315 equals 27x. Last step is divide by 27, the coefficient. Now what we get here is 11.6 repeating. So you can write your answer as 11.6 repeating. As a decimal, it would be as a fraction, it would be 35 over 3. So that would be an inverse variation problem. Okay, so that's the end of part 1. That's the front of the notes. Go ahead and turn them on the back, and we'll start part 2.